This is Radhika. I am going to discuss about the subject power electronics, and in this, today I am going to discuss about the SCR ratings. In last class, we discussed about the VA characteristics and the construction of SCR. So, in today I am going to discuss about the ratings of SCR. So, in this, so already in last class we discussed the construction and operation of SCR, and also we discussed two transistor analogy of SCR and VA characteristics of SCR. Now today we are going to discuss about the thyristor ratings, means voltage rating, current ratings, and it has the lot of ratings. So actually what is the ratings of SCR? So here every power semiconductor device has a limited capability of handling the power, that is voltage and current. Basically, it depends upon the temperature withstand capacity of PN junctions during steady state and dynamic conditions. Normally, the power semiconductor device has the limited capability of handling the power. So it depends upon the temperature withstand capacity of PN junction during steady state and dynamic conditions. After complete testing a particular device, manufacturers prepare the device specifications. It specifies critical values of different parameters and the safely operating regions of the device. In SCR ratings are classified into mainly three types. The thyristor ratings have the safety working margins which are little bit higher than normal working value. For reliable operation of thyristor, it should not exceed the safety working margins, otherwise the thyristor gets damaged. So here, in thyristor ratings, the thyristor ratings have the safety working margins which are little bit higher than normal working values. For reliable operation of thyristor, it should not exceed the safety working margins, otherwise the thyristor gets damaged. So, in this, in SCR ratings, we have the few classification that are the continuous rating, repetitive rating, and non-repetitive or surge rating. So, these are the three classification of SCR ratings. In continuous rating, these are related with the continuous working conditions of the devices. It is expressed in terms of average or RMS values, depending upon whether the device is operating with unilateral or bilateral voltages. In repetitive rating, this rating is useful when the device is switched on periodically. And in third, non-repetitive or surge rating, a surge rating corresponds to the maximum permissible non-repetitive current and peak voltages which the device can withstand during a surge. During the condition, the junction temperature exceeds the permissible value for a short time only. So in continuous rating, three ratings are related with the continuous working conditions of the device. So here, a second is the repetitive rating. In this, this rating is useful when the device is switched on periodically. And third is the non-repetitive or surge rating. A surge rating corresponds to the maximum permissible non-repetitive current and peak voltage which the device can withstand during a surge. So here in this, we have the normal representations of SCR ratings, means general thyristor ratings. These are the 8 that are anode voltage ratings, current voltage rating, power voltage ratings, dV by dt ratings, di by dt ratings, and turn on and turn off times, latching and holding currents, and temperature ratings. So these are the few SCRs generally represented ratings. So in this, uh, first of all, we are going to discuss about the anode voltage ratings. So before going to that, we have the few notations of subscripts for the representing the SCRs. In this, we are using the some letters as the indicators. So first, D, capital D means the forward blocking state or off state. Here is the symbol, capital D is the forward blocking state or off state, and capital T is the on state, and R, capital R is the reverse state, and capital F is the forward, except for the gate terminal. And also second subscript letter indicates the operating values, or the capital W is the working value, capital R is the repetitive value, and S is the surge, means non-repetitive value, and T is the triggering value. And these two are the main subscriptions. And also last subscript letter indicates the maximum or peak value. So next, these are the subscriptions. Now we are going to discuss about the anode voltage rating. Anode voltage rating. So here in anode voltage ratings, so a SCR means it is the thyristor is made up of 4 layer and 3 junctions. Already we discussed in previous classes. The middle junction J2 blocks the forward voltage, and the two end junctions J1 J3 blocks the reverse voltage. The anode voltage rating indicates the value of maximum voltage that can be applied across the device without causing any breakdown at a junction area. Means in SCR, actually the SCR will be made up of semiconducting materials of P-type and N-type, and it has the 4 layers and 3 junctions. In middle junction, J2 blocks the forward voltage, and two end junctions J1 and J3 blocks the reverse voltage. The anode voltage rating indicates the value of maximum voltage that can be applied across the device without causing any breakdown at the junction area. So in this, the anode voltage rating have the few wordings that are the peak working forward blocking voltage, and peak repetitive forward blocking voltage. In peak working forward voltage, it is the maximum forward blocking voltage that a thyristor can withstand during its working, and it is the maximum forward blocking voltage that a thyristor can withstand during it works. And also it has the peak repetitive forward blocking voltage. So it is the maximum transient voltage that a thyristor can withstand repeatedly or periodically during the forward blocking state of off state. It is specified at a maximum allowable junction temperature with gate circuit open, or with a specified biasing resistance between gate and cathode terminal. So in this, The maximum allowable junction temperature with the gate circuit open or with a specified biasing resistance between gate and cathode terminals. So in this, these are the peak working forward blocking voltage and peak repetitive forward blocking voltage, and also it has the peak surge forward blocking voltage. That means it is the peak value of forward surge voltage that does not repeat, it does not repeat, and also its value is about 130% of um, VDRM. So VDRM means it is the peak repetitive forward blocking voltage. So here in this, next is the peak repetitive reverse voltage. It is the maximum reverse voltage that may occur repeatedly in the reverse direction at the allowable maximum temperature that can withstand by the thyristor without breakdown. So next is the peak surge reverse voltage. So it is the maximum transient reverse which can be safely blocked by the transistor. Its value is about 130% of VRRM, means peak repetitive reverse voltage. And next is the VT, means on state voltage. Is the on state voltage. So here on state voltage, it is the voltage drop between anode and cathode during forward bias, and its value lies between 1 to 1.5 volts. And next is the forward dV by dt rating. So it is the maximum rate. It is the maximum rate of rise of anode voltage that will not trigger the thyristor without any gate signal. And also, if the rate of rise of anode voltage is higher than the specified maximum value, the thyristor may cause switching from off state to on state. So, when a forward voltage is applied across thyristor, a current I C into dy by dt will flow, and this current will act as a gate signal. Hence, the thyristor will be turned on. Due to this, dV by dt triggering is never employed. So, these are the few topics in anode voltage rating. So in this, main are the is the peak working forward blocking voltage and peak repetitive forward blocking voltage and peak surge forward blocking voltage and peak repetitive reverse voltage, peak surge reverse voltage, on state voltage and dV by dt rating. So this is the only anode voltage rating. Next we go for current ratings. So actually, what are the current ratings? There are different current ratings established here. So here there are different current ratings established with repetitive and non-repetitive waveforms of current. Current should not rise the thyristor junction temperature rapidly, even for short overloads of currents. And here in this, in current ratings of SCR, the uh, the thyristor junction temperature rises rapidly even for short overloads of current. Hence, the heat is developed and dissipated in the form of power. For satisfactory operation of a thyristor, the junction temperature under steady state condition should not exceed the safe value, which is usually 125 degrees centigrade. So there are different current ratings established with repetitive and non-repetitive waveforms of currents, that are normally average current rating, RMS current rating, surge current ratings, I square T ratings, dA by dt ratings, So these five are undercomes in current ratings. So in this average current ratings, the power loss in the thyristor depends on value of average current flowing through it. In this, the variation between average power loss and average current in a thyristor for different conduction angles alpha means 30 degrees to 180 degrees with the working frequencies from 50 to 400 Hz. In RMS current ratings, the RMS current rating of a thyristor is specified in order to prevent the excessive heating in the resistive elements such as metallic joints, it leads and interface etc. The RMS value of current for different conduction angle remaining same. So in this, the surge current ratings when a thyristor is working under its repetitive voltage and current ratings, its permissible junction temperature will not exceed. In order to withstand the thyristor under abnormal operating conditions due to faults or short circuits, it is necessary to specify the surge current ratings. A surge current rating indicates the maximum possible non-repetitive or surge current with which the device can the maximum possible non-repetitive or surge current with which the device can withstand. The surge current rating of a thyristor is inversely proportional to the duration of surge. I square T rating. In this rating is mainly employed to operate as a fast acting fuse for protecting the device during an overload or fault conditions. In this, the rating will measure the thermal energy that the device can absorb for a short time before the fault is cleared by the fuse. I square T rating is given by RMS value of one cycle surge current square into time for one cycle. So in this is the last one di by dt rating. So in this the rating of a thyristor indicates the maximum rate of rise of current from anode to cathode without any damage to the device. So when a thyristor is turned on, the conduction starts at a place near the gate. If the rate of rise of anode current di by dt is large, is compared to the spreading velocity of carriers across the cathode junction, local hotspots will be formed near the gate connection on account of high current density. This causes the junction temperature to rise above the safe limit. Due to this, the thyristor may damage permanently. This typical value of di by dt rating lie between 20 to 800 ampere per microseconds. So this is the current rating of SCRs and uh, next we go for turn on time. So turn on time of the SCR, the turn on time by the SCR to reach full conduction state is called turn on state. The time taken by the thyristor to reach full conduction state is called turn on time. So turn on time consists of two parts, namely delay time Td and rise time Tr. After triggering the thyristor, it does not conduct instantaneously but takes infinite time to reach full conduction. This time is called turn on time. So this is the diagram for turn on of SCR, turn on time of SCR. So in this it has the anode current and gate current. So is the anode current and gate current. So this is the 0.9 TR. So here TD is the delay time and TR is the rise time. So in this it has the x-axis and y-axis. In y-axis it takes the anode current above diagram, and below diagram it in y-axis it takes the gate current, and also it has the time TD time. Here in x-axis it has the TD time, that is the delay time, and TR is the raise time. Means when the thyristor starts conducting, it has the some delay time. Mean it will be shows in degrees, means 10 degrees, 20, 30. It will be maximum up to 170 degrees. So it has the to conduct the SCR, it has the delay time and raise time. So this is the diagram for turn on time. And also here the turn on time is the T on is equal to TD plus TR, means delay time and rise time. Turn on time of SCR lies between 2 to 10 microseconds dV by dt ratings. It indicates the maximum rate of rise of voltage from anode to cathode without any harm to the device, di by dt rating. It indicates the maximum rate of rise of current from anode to cathode without any harm to the device. So here next is the turn off time. So in turn off time, it is defined as the time required from the zero current point to the time when the thyristor regains its full blocking voltage in positive direction after the application of reverse voltage. It mainly consists of time for reverse recovery current flows after the application of reverse voltage. Means time for reverse recovery current flows after the application of reverse voltage TRR. So here when reverse voltage is applied to thyristor, the time taken from zero current point to time when thyristor regains its full blocking voltage is called turn off time. The turn off time consists of reverse recovery current time TRR. So TRR is called reverse recovery current time. And also it has the TR, means that is the recombination time. Turn off time is equal to reverse recovery time plus combination time, that is TRR plus TR. So circuit turn off time must be greater than the device turn off time for safe turn off. So this is the diagram for turn off time. So in y-axis it has taken the voltage, and in x-axis it is the time. So here the TRR and TR. So in the TRR is the in this TRR is the reverse recovery time, and TR is the combination time. So this is the diagram for turn off. Turn off time of SCR is lies between 50 to 200 microseconds. Next is the temperature rating. So the temperature rating is the thyristor temperature rating is the junction temperature rises rapidly even for short overloads of currents. Hence, the heat is developed and dissipated in the form of power. Means the power will be lost. Means there is the loss of power. It will be in the form of heat. For satisfactory operation of a thyristor, the junction temperature under steady state condition should not exceed the safe value, which is usually 125 degrees. So we are discussed about the rating of SCR, and also for more explanation we are going to watch the one YouTube video.
Hi, welcome to Bicycle Academy, India's first smart gate coaching institute. Myself Shekhar. In this lecture, I'll talk about voltage rating of SCR. First of all, let me talk about what is a rating. What is meant by rating? In electrical engineering life, we always come across a rated voltage, a rated current, or maybe rated power, rated speed. They are the most, most of the times we come across these four terms. What is meant by rated or rating? Which means the device, any device, maybe machine or transformer, any device, maybe bulb. Let me take an example of bulb. Of course, bulb doesn't have any speed. Okay. Let me take rated voltage for the bulb is 100 volts. What does it mean? It means if the bulb is supplied with more than 100 volt, if bulb is supplied with more than 100 volt, then bulb will be damaged. The bulb will be damaged. If the voltage is less than 100 volt, then the output may not be as it is designed to give. Okay, rated voltage means that's a value at which the bulb will work as expected. Above this value, it will be damaged. Below this, okay, you can operate. Less than that, it's okay. It will give less intensity, not as or expected, but okay, it will not be damaged. But more than this, there is a chance that it may be damaged. Okay, so that's what the rated term means. Similarly, rated current, rated power, rated speed, anything. Okay. So I think rated term is clear. Now come to voltage rating of an SCR. Why are we more particular about the ratings of power electronic devices? We have not studied so much about these ratings in other courses. In machines also we don't much worry about this. But in power electronics, we are focusing on these ratings also. Why is it so? Of course, every operator's rating is very important. But for sensitive devices like power electronic devices, we should be more concerned about it. I mean, we should be more concerned about the ratings. Sensitive means, what is meant by sensitive? Small disturbances, maybe for a small time, that could damage the device very quickly. Like girls are more sensitive. We should be more particular about what to talk with a girl, what not to talk. When you're talking to your girlfriend, you should be very careful when you're talking. If you say, if you're a little aggressive, then she may feel bad, she may feel hurt. Okay, so you should be very careful when you're talking to your girlfriend, because not necessarily girlfriend, maybe a girl, okay, any girl, because girls are sensitive, so you should be very much careful. Okay, when you're dealing with the sensitive devices. So obviously, the power electronic devices, they handle high amount of power and they are sensitive too. They're very sensitive too. So that's why we should be more particular about these ratings of these SCR or maybe any other power electronic device. So before getting into that, let me just recall operating modes of an SCR. What are the operating modes of an SCR? Forward conduction state, forward blocking state, reverse blocking state. They are the operating modes of SCR. And these in SCR basic schematic diagram. Okay, and we'll normally have voltage here. Forward voltage, of course, through some load, there will be load. I think I should make that also. Otherwise, it will be a short circuit kind of a thing. Yes, this is a load. We have load and it's applied like this. And this is a control signal is here. Control signal is given over here through some resistance and some other circuitry is okay. Okay, basic things I am giving it. So obviously this voltage, how much is this voltage I should apply, voltage rating, that we know. And this voltage, gate voltage, as we have two parts, one is main power circuit, this red one is called as a power circuit, this is called as gate cathode circuit, control circuit. This is a control circuit and this is power circuit. Okay, so this will have separate ratings, this will have separate ratings. Yes, they are independent completely. And not just this voltage, there are lot many other voltages, because it's a girlfriend, it's your girlfriend. So every moment you should be careful. Under normal case, how she will respond. If there is a little disturbance, whether she can hold or not, your girlfriend, whether she can hold or not. If it is a big disturbance, whether she can hold or not, she can, she can be comfortable or not. That's what I'm trying to say. Okay, so you should be careful with each and every aspect. Let's see what is that. Okay, what kind of ratings we normally specify. Let me just show you that. Yes, they are the voltages, voltage ratings. On state voltage. On state voltage, simply VT, means when device is conducting, that's what I said, forward conduction state. During this state, for every state, you are stating, okay, what kind of rating is there in that time, during that time, what is the rating? During this state, what is the rating? Okay, that's what forward on state voltage. On state voltage means when it is conducting, the on state voltage drop is across the junction. So normally value is 1 volt to 1.5 volt. And we have here control circuit for gate. So what is the minimum voltage? What is the minimum gate voltage required to produce a triggering current? Gate triggering current, how much is the minimum voltage which is required? Okay, these are the two ratings. And then these are the main points. Working peak of state, repetitive peak of state, non-repetitive peak of state, working peak voltage, reverse repetitive peak, non-repetitive peak. Let me explain all these things with the help of simple animation. Let me show you that animation. Yes, look at this. This is what you're expecting to, feed to the supply power circuit of the SCR. This is what we're expecting, smooth and sexy sinusoid. So this is what expected and we're getting it. But sometimes your girlfriend may not receive as expected. There could be some disturbance. Not a sinusoid. There are some pulses here, see? Some spikes have come. And they're repetitive for every one cycle. In one cycle we have here, and in the next cycle also we got it, in the third cycle also we got it. So we're expecting life will be smoother with a girlfriend, but some disturbance regularly coming. So if regularly coming for a shorter time of course, not for a longer time. Let's say this is a whole day. One cycle is 1 day. Not an entire day, you are having some unexpected situation at one point of time. Okay, every day you are having it. That's what repetitively you are having every day. This is one case. Just take this case. I'll explain about these cases a little while later. And the second case is, you are having little big disturbance. See here, this is little bigger disturbance. But not every day. On this day we don't have anything, on the second day you have something, maybe on the third day you don't have anything again. So this is something peculiar and non-repetitive. This disturbance is not repetitive, it comes once in a while. Okay, and this is during the forward bias. See, this is during the forward bias. Same is true obviously for the reverse bias also. Reverse bias also you may have it. It's a possibility, just a possibility. And non-repetitive, this is a repetitive one, but this is non-repetitive one. Once in a while you are getting this. Okay, so whether it can withstand, whether your girlfriend can withstand this kind of big disturbance or not, if she can withstand, how much big it can withstand, these are all things are the different other ratings of thyristors. Okay, So let me just explain that with the help of this VI characteristics of SER. I think all of you must be familiar by now with this SER. You must be familiar, then only you will understand this topic. Okay, familiar means basics. So this is forward breakover voltage, and this is reverse breakover voltage. Okay, and here I have letters D. D, whenever I have D, it is for forward. D stands for forward blocking region. Forward blocking region. W stands for, here we have W, here also we have W, working. Means regular case. Working means regular case. A regular working case. Small r represents repetitive. Small r here, here also we have small r. Capital R represents reverse. D is for forward blocking, R is for reverse blocking. Okay, and M stands for maximum. Okay, this forward breakover, this is reverse breakover. And there is one more thing, S stands for surge, or maybe non-repetitive. Surge or maybe non-repetitive. So let's bring that wave shape once again. What we got? These are one. Here, this is just let's see without this. This is a regular voltage peak. This is a regular voltage peak. So I'll call it as D for forward, of course voltage, D for forward, working maximum. Regularly we are supposed to get this regular cases, but under some situations you are getting this small notch and which is repetitive. So let me call it as forward, so that's why I'm writing with the D, and repetitive are maximum value. I'm talking about a maximum value. And this one is voltage forward case, non-repetitive or maybe surge means which is non-repetitive. Once in a while it used to come, like a cyclone. Okay, once in a while it used to come. So like this. Same thing is true for a reverse bias also. This is VRWM, reverse working maximum, and this is, tell me what is this? Reverse repetitive maximum value, and this is reverse non-repetitive maximum value or reverse surge maximum value. Okay, I think you understand what are these 6 terms. Basically, if you understand these 3, forward case, reverse case also, it is just same. Okay, relate your girlfriend or maybe relate your boyfriend, you will understand things better. Okay, whether they can withstand this much or not, they can withstand this much or not, that's the point. Can, capability. Okay, it's not that they are always withstand that. They can withstand a sudden small big disturbance for a shorter time. Once in a while, of course, one can withstand. Okay, so that withstand capability is shown over here, how much they can withstand. Okay, so let's go to the regular one. Yes, they are the things, whatever I explained here, they all kept over here. You can read it, you can pause the video and read all these things. Then the next rating is voltage safety factor, VSF. To avoid the damage of thyristor due to uncertain conditions, normal operating voltage is kept well below this voltage. Means suppose your girlfriend can withstand certain amount of pressure. Okay, your girlfriend can withstand certain amount of pressure. But as a factor of safety, you should not keep that much amount of pressure. Though she can withstand, but there is a slight chance that if it is little more, then she is gone. You're gone and break up. So you should always play in a safest manner as in, suppose if she can withstand this much, try to put 50% of the pressure. Don't put 100% of the pressure. Okay? Because if it is a little more also, then it is well within the limits. There won't be any problem. So that's what the factor of safety, voltage safety factor. It can withstand peak repetitive reverse voltage of this much, but as a factor of safety, we always keep 2 to 2.5 within our limit. Means though it can withstand this much, we don't put that much voltage. We normally operate 50% lower value than its capacity. Okay, 50% lower value than its capacity, because it's very sensitive device. Why I'm saying girlfriend? Because they are also sensitive. These are also sensitive, pretty much sensitive. Yes, I damaged many SCRs. When I was experimenting with SCRs, I think if I say the number, it will be too big. Okay, during my experimental stage, I damaged hell number of SCRs. Yeah, next, forward dV by dt rating. I think this you will understand well better, and you will understand better this one during triggering methods. Triggering methods, dV by dt. This will not damage the device, but this will trigger the device. That's what a mal triggering, unnecessary triggering. Okay, so this is a dV by dt rating. Normally, people will have a doubt here. What is the difference between voltage rating, a general voltage rating, and dV by dt rating? Let me just brief that point here. Suppose a device can withstand 500 volt. Okay, a device can withstand 500 volt, but I have applied 50 volt only. 50 volt only applied. So 500 is the capacity. I have applied only 50 volts, but still this could be a problem. Still this could be a problem. Why this could be a problem? That's because of the dV by dt. What is this dV by dt? dV by dt says at what rate this voltage is changing. dV by dt doesn't talk about absolute number, how much is the voltage. It talk about what rate, what is the rate of change of voltage. Is it the change is happening, the 500 volt change is happening in this fashion, or very slow like this, or very slow like this. Okay, this will talk about the rate of change of voltage, not about the voltage magnitude. Careful with that. That's the difference. You will understand this during turn-on methods. What could be the problem? You can read this also. Next, finger voltage. This also you'll understand during, you must have understood during rather about the finger voltage of SCR during the VI characteristics or static characteristics of SCR. Static characteristics of SCR. During that time, how gate voltage, current will affect the forward breakdown voltage. That during that time we'll understand this. The last one is valve rating. What is a valve rating? It's simply ratio of PIV, peak inverse voltage, to the average DC voltage. Okay, this is mainly, this will discuss about the valve utilization. Means how much the device is being utilized, whether it is fully utilized or underutilized. You should not even fully utilize complete 100%. You should not even underutilize it. What I mean to say is, if I give an example, there is no point of gifting iPhone to your grandma. It's good to gift iPhone to your girlfriend, but it's not good to give iPhone to your grandmother. Why reason? It's not because she's not your girlfriend. Of course, grandmother is much more important than your girlfriend, but it's not worth to give it to her. Worth to give it to your grandmother iPhone gift, because she can't use iPhone properly. She can't use full functionality of iPhone properly. Of course, I'm not talking about today's grandmothers. Maybe they might be very few, might be very much acquainted with these iPhones. They can make use of this iPhone, but most of the cases I'm saying, there is no point of gifting iPhone to your grandmother because it will be underutilized. Okay, so that utilization point, that valve utilization, this valve rating will give it PIV2 average DC voltage. That's it. I think you understand these voltage ratings. If you like the video, hit the like button and share this video with your friends. And again, if you're new to the channel, don't forget to hit the subscribe button so that you will.
So this is the discussion about ratings of SCR, and in this we discuss the summaries. For the reliable operation of the thyristors, the thyristor should operate it within specified limits, and these safe limits are called as thyristor ratings. So turn on time of the thyristor is of the order of 2 to 10 microseconds, and turn off time of the thyristor is order of the 50 to 200 microseconds. And here we have the few quiz questions and frequently asked questions, and this is the class of ratings of SCR. In next class we will discuss with another topic. Thank you.